Think about what happens outside your window every year. The deep snow of winter melts away, giving way to the lush green canopy of summer. It feels intuitive to assume that when we experience extreme heat, it's because our entire planet is closer to the sun, and when we freeze, we're further away. This diagram shows Earth's elliptical orbit around the sun. We do physically move closer and further away over the course of a year, but those varying distances do not line up with the timing of summer and winter. Since proximity to the sun isn't generating the heat of July or the cold of January, an entirely different, unseen mechanism must be controlling our planetary climate clock. To understand our climate, look at the rotational axis, the invisible line our planet spins around every day. But Earth doesn't spin perfectly upright compared to its path around the sun. It leans. The axis is angled at exactly 23.5 degrees. Because of this exact tilt, the Northern Hemisphere receives intense, direct solar radiation for half the year, while the Southern Hemisphere receives sunlight at a lower, weaker angle. 6 months later, the positions reverse. In physics, a planet forming from a flat, spinning disk of gas and dust should naturally end up spinning straight up and down. A tilt this heavy is a clear anomaly. For a planet the size of Earth to be knocked this far off its vertical axis, it had to have been struck by an immense cosmic force. 4 billion years ago, the early solar system was a chaotic shooting gallery. Gargantuan fragments of rock and ice were constantly colliding as planets began to form. Traveling through this early debris field was a Mars-sized protoplanet that scientists call Theia. Theia's orbital path crossed with the young Earth. The two bodies slammed into each other, vaporizing vast volumes of rock into the vacuum of space. The sheer kinetic energy of this strike permanently pushed Earth's rotation off its upright axis, leaving it with the 23.5-degree slant we have today. The millions of tons of molten debris ejected from that collision eventually coalesced in orbit, forming our moon. The strike that created our lunar companion is the exact same event responsible for the seasonal cycles we experience today. An isolated planet tilted at 23.5 degrees lacks inherent stability. Without an anchor, the angle would wobble erratically over time. If Earth drifted to a 0-degree tilt, the sun would uniformly hit the equator, erasing the seasonal biological clocks species rely on. Conversely, at an extreme 45-degree angle, the poles would face months of intense radiation, followed by total freezing darkness. Fortunately, the moon's substantial mass exerts a constant gravitational pull on Earth. This pull acts as an anchor, securing our axial tilt firmly in place. The moon serves as a gravitational stabilizer, securing our tilt and preventing the extreme climate swings that would otherwise sterilize the surface. Even with the moon acting as an anchor, Earth's tilt is not perfectly frozen. It slowly oscillates back and forth within a narrow window over tens of thousands of years. This slow, rhythmic wobble is a central part of what astrophysicists call the Milankovitch cycles. When you look back at geological records, these microscopic, long-term shifts in Earth's angle align tightly with profound historical climate shifts, including the ice ages. The great glacial expansions of the past were driven by these planetary mechanics, in stark contrast to the brief window of climate stability human civilization has evolved within. Our long-term climate is ultimately dictated by this slow, intricate gravitational dance with the rest of the cosmos. This brings us back to the surface. The 23.5-degree angle precisely dictates how heat is distributed across the continents. The difference in temperature between the equator and the poles drives our atmospheric currents and the global water cycle. This cycle of evaporation and precipitation supports a vast array of ecosystems, all operating on the predictable rhythm of the changing seasons. And human civilization relies completely on this system. Our entire global agricultural network is timed to the specific seasonal clock created by our planet's slant. Every summer breeze, autumn harvest, and winter snowstorm is the direct, ongoing echo of a collision that happened 4 billion years ago. A random, catastrophic cosmic accident is the reason Earth is a perfect world for life.